Yeah. So hi guys. Hi once again. So today in the last class we have been discussing about the sign magnitude method. So in this sign magnitude method we observed that one extra bit was being used where if that particular bit value is 1 it will be a negative number. If that particular bit value is 0 it represents a positive number. And the major disadvantage of the sign magnitude method was it had two representations for 0 which was wrong which can lead into a chaos. So that's the reason why we are today whatever the topic which we are discussing is about the ones complement. So so today our topic will be on the ones complement. Ones complement. Okay. Just a second. So most of the students who approach me are earlier when I was tutoring them or who generally right now also they approach me, they consider this particular one's complement as a very wrong. So what is that particular mistake in the understanding of the students? I will be explaining it today. So generally, as the name itself will suggest that one's complement is nothing but we are going to invert. So what we are going to do? We are going to invert zeros and ones. Means if we want to invert zeros, they should become ones, and if we want to invert ones, they should become zeros. But there is a main problem in this particular thing, in the understanding. So generally, why do we use this ones complement sign magnitude and the two's complement one to represent the negative numbers? To represent negative numbers. Okay. So now let us just try to go through the means how to represent or with an example. Let us just go through this particular things. Okay. So mm. so as in the previous example, to make the video as a crisp one, let us consider it for the from -3 to +3. -3, -2, -1, 0. Last time we have also seen -0. So let us see that -0, +1, +2, and +3. So just for a small change, let us take the minus on this particular side and plus. Okay. So generally, the mistake which the students will always understand is whenever if I'm taking +0, if I ask the student or if I ask a few people to find out the ones complement of this one, immediately their idea will be like they will be considering this one like 0, 0, 0, which is nothing but 1, 1, 1. So they tell for +0, 1, 1, 1 will be the ones complement equivalent, which will be a wrong one. Why? Because ones complement is only for negative number representation. So we should consider only the negative numbers. One's complement should be taken only for the negative numbers. So for the positive numbers, it remains one and the same. And one more point. Here for representing the 3, 2 bits are enough for us. Okay. So for suppose if it is +3, 1, 1, +2, 1, 0, +1, 0, 1, 0, 1, +0, 0, 0. So generally for representing the 3, 2 bits are enough for us. But for the extra bit is being used for the representation of sign. Is that okay? So now the first point which we have observed for the day is one's complement need to be considered. One's complement should be computed for negative numbers only. So this is this is the point which I want to highlight, because most of the students who reach me, they will be trying to figure out the same thing, and when I tell this point, they will be like shocked or astonished with it. So the second point, how can I compute the ones complement? So in order to compute the ones complement, what I'm doing is here, how can I represent minus 0? It is 0, 0, 0. And if I'm taking the ones complement of it, this one has to be 1, 1, 1. And the above one should be 0, 0, 1, 0, 1, 0. It is 0, 1, 1. Okay. So this has to be 1, 1, 0. This has to be 1, 0, 1. This has to be 1, 0, 0. So you can see that we have computed the ones complement equivalent successfully. Is that okay? And there is one more problem on this side. Whatever the problem which we have seen in the sign magnitude method, the same problem is being occurring here also. What is that issue? Two representations per zero. Two representations for zero. There are two representations for zero, which should be again a drawback. Means if I'm telling it as a drawback, it doesn't mean that we don't use ones complement anywhere. There are a few circuits where we prefer the ones complement. Okay. So, so these are the two different things which we should be able to understand from the ones complement. Now, whenever I discuss this particular thing, the first point which the student or someone should get the idea is, if an value is given, how can I compute its equivalent? If the ones complement equivalent value is given, how can I compute its value back to a normal number? So generally, let us take two examples to figure out this situation. So one is nothing but the example one. Okay. So what does so if one's complement representation, so in the one's complement representation, a number is being given like 1000 to the base of 2. Now find its equivalent value. So it is being given that it is in the one's complement form. We need to find its equivalent form. Is that okay? So whenever I want to do this, the first step which I should do is first compute the or consider the MSB. If the MSB value is 1, we are going to consider it as a negative number. If the MSB value is 1, we are going to consider it as a negative number. If it is a negative number, we will be applying the ones complement equivalents. So which is nothing but 0, 1, 1, 1 to the base of 2. So here it's a negative number and the magnitude states it's 7. The magnitude is 7. So therefore, 1,000 to the base of 2 in the ones complement equivalent representation represents minus 7 to the base of 10. So similarly, let us take one more example just for our analysis purpose. So, so let this be the example 2. So here let us consider 0, 1, 1, 1 to the base of 2 is in the ones complement representation. And we want it equivalent to the base of 2. So here we are going to consider this one like the MSB is 0. So if the MSB is 0, it represents a positive number. If the MSB is 0, it represents a positive number. So now the magnitude is 7. Therefore, 0 triple 1 to the base of 2 represents plus 7 to the base of 10. So this is how we can convert an ones complement equivalent number to the actual form. So now generally in the last discussion we discussed about the range. Okay, so for n bit representation, what is the range? So this time also, as in the similarly as in the previous example, if I'm taking the n bit, okay. So in our example, we have taken 3-bit representation for which we were able to compute from -3 to +3. Is that okay? So now the similarly, so I can write down -3 as minus 2 power 2 square minus 1 to 2 square minus 1. And similarly here 2 square will be nothing but 2 power 3 minus 1 minus 1 to 2 power 3 minus 1 minus 1. So here I will be replacing n with the 3 here because we had n equals to 3. Therefore, minus of 2 power n minus 1 minus 1 to 2 power n minus 1 minus 1. So this will be the range of representation for ones complement equivalent, which is same for the sign magnitude method all even. So this is the range. Okay. So totally the three important points which we need to remember. The three important points which we need to remember are the ones complement should be computed only for the negative numbers. That there will be two representations for 0 even in the ones complement equivalent format, which is a drawback. And the third point is the range is nothing but minus 2 power n minus 1 minus 1 to 2 power n minus 1 minus 1. So this is the range for the ones complement equivalent. So thanks for this, and we will be meeting in the next video with the twos complement equivalent.